Here is a question that sounds simple. What is a moon?
Something that goes around the planet.
Right. And what is a planet?
Something that goes around the star.
So, what do you call a Jupiter-sized world that orbits an object that is not quite a star and not quite a planet, which is itself orbiting a star 70 light-years away?
I am going to need a minute.
So does the International Astronomical Union.
We'll get back to that.
Hello, and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It is Friday, the 24th of July, 2026, and this is episode 149.
Coming up, astronomers confirm the first moon-like object outside our solar system and immediately break the vocabulary trying to describe it. We have found the most powerful particle accelerator in the galaxy, and it has been sitting next to one of the brightest stars in your sky. A black hole is starving a galaxy it doesn't even live in.
China flies the world's biggest solid rocket from the open ocean for the first time. Starship gets another shot at Flight 13, tonight for some of you. And the moon has a date with the heart of the scorpion.
Let's get into it. We have found thousands of planets around other stars, nearly 6,000 confirmed, with candidates stacked up behind them. But there has always been a conspicuous gap in the catalog. No moons, not one confirmed. We know moons must be out there. Our own solar system has close to 300 of them, but they are small, they are faint, and they are parked right next to something far brighter. Finding one has been one of the great frustrations of exoplanet science.
And now?
Now, a team publishing in Nature has confirmed the first one, sort of, and the sort of is the whole story. The system is a star called CD-352722. It is a red dwarf, roughly 70 light-years from us. And for our listeners in Australia and New Zealand, it sits in your southern sky. Astronomers have known for years that this star has a companion because the star wobbles. That companion is called CD-352722b, and it is heavy, somewhere between 29 and 38 times the mass of Jupiter.
That's well past planet territory.
It is. Above about 13 to 15 Jupiter masses, an object can fuse deuterium in its core. It's not doing what the Sun does. You need around 90 Jupiter masses to fuse ordinary hydrogen, but it's doing something. That in-between category is a brown dwarf, too big to be a planet and too small to be a star.
The thing astronomers call a failed star, which always struck me as unkind.
Deeply unkind. And this particular brown dwarf is bright enough and far enough from its star that the Very Large Telescope in Chile can photograph it directly. So the team took spectra of the brown dwarf itself and found that it wobbles too. Something is orbiting the brown dwarf. Best estimate of its mass, about 1 Jupiter.
So we have a Jupiter going around the brown dwarf going around the red dwarf.
A 3-tiered system, and nobody can agree on what to call the object at the bottom.
Because if the brown dwarf counts as a planet, then this thing is a moon, an exomoon, the first one confirmed. But if the brown dwarf counts as a star, then this thing is a planet and it's not a moon at all.
And the brown dwarf is genuinely, physically, both and neither. The paper hedges by calling it an exo-satellite, which is honest and also a bit of a shrug.
We've been here before, though. This is the Pluto argument in a fresh outfit.
It really is. Pluto is not a planet because it has not cleared its orbital neighborhood. Fine. But Pluto has Charon, and Charon is so large relative to Pluto that the two of them orbit a point in empty space between them. So is Charon a moon of a non-planet? Are they a double dwarf planet? And our own moon is bigger than Pluto. Should it be a dwarf planet that happens to be captured?
Nature does not care about our filing system.
Nature does not care at all. And here's the part I find genuinely exciting. Brown dwarfs are common. If this one has a Jupiter mass companion, plenty of others probably do too. Some of those could sit in the habitable zone of the parent star. You could have a warm, temperate world with liquid water orbiting a failed star, orbiting a real one.
And we would not have a word for it.
The team says this is the first of its kind, not the last. I suspect the IAU is going to have a long decade.
Now, if you go outside tonight and look up, one of the first bright stars you will find is Altair. Northern listeners, it is high overhead in the evening, the southern corner of the summer triangle. Southern listeners, look north. It's lower down, but it's unmistakable.
One of the closest bright stars to us, 16.5 light years.
16.7. Now, roughly in that same direction, but nowhere near it in actual space, sits an object that has just been confirmed as the most powerful particle accelerator in the Milky Way. By the way, I should stress the nowhere near it as the key point here.
Worth being precise about that. Same patch of sky, wildly different distance.
Wildly. Altair is 16 light years away. This thing is closer to 14,000. It just happens to line up. It's called LHAASO J1912 plus 1014U, which I'm going to say exactly once, and it was picked up in 2024 by a Chinese observatory high on the Tibetan Plateau.
And what makes it special?
It's throwing protons out at more than 1,000 trillion electron volts, 1 PeV. Astronomers call an object that can do that a pevitron. And it's worth pausing on what that number means. The Large Hadron Collider is 27 kilometers of superconducting magnets buried under the French-Swiss border. And it's the most powerful machine humanity has ever built for this purpose. This object beats it by a factor of well over 100.
With no magnets and no budget.
With no magnets and no budget. Now, we've known about pevitron candidates for a while. There are dozens of them. The problem has always been proving what's actually being accelerated, because when you detect very high-energy gamma rays coming from one of these sources, there are two ways to make them: protons smashing into gas, or electrons scattering off light. Both produce gamma rays. The observatories that found these sources can't tell the two apart, because their images are too blurry to see the difference.
So how do you settle it?
You stop relying on one telescope. A team led by Tsunefumi Mizuno at Hiroshima University pulled together 3 completely different instruments looking at 3 completely different kinds of light. NASA's Fermi Space Telescope for gamma rays at lower energies, a Japanese radio survey from the 45-meter dish at Nobayama, which maps the cold gas clouds in that region, and NASA's Chandra Observatory for X-rays.
3 views of the same patch of sky.
And the pattern only works one way. Fermi found an excess of gamma rays at exactly the energies you'd expect if protons were slamming into gas, and the radio data showed the gas was right there for them to slam into. The electron explanation doesn't fit the shape of the signal, so this is a proton accelerator, confirmed in the Astrophysical Journal.
What was it originally thought to be?
A supernova remnant, the expanding wreckage of a dead star. Perfectly reasonable until it started putting out gamma rays above 100 trillion electron volts and stopped being ordinary. And it is big. On the sky, it spans more than 1 degree, twice the width of the full moon.
Which matters because cosmic rays are not just an abstraction. They are hitting us constantly.
Constantly. They are a genuine hazard for astronauts and for spacecraft electronics, and they play into the chemistry of the interstellar medium. Knowing where the most energetic ones actually come from is not a trivia question. The team says there are dozens more candidates to work through, and now they have a method that works. Expect more of these. Next up, Story 3, The Starved Red Potato.
Avery, imagine a desert right on the coastline, ocean stretching to the horizon on one side, and almost no rainfall for years at a time.
The Atacama, or the Namib.
Exactly those. All that water sitting there right there, and none of it arriving. That image is what got an astronomer in Milan thinking about a galaxy.
Go on.
Back in January, we got word of a galaxy nicknamed the Red Potato, named with real scientific rigor for looking like a red potato in the JWST image. It's more than 11 billion light years away. We're seeing it as it was when the universe was under 2 billion years old. And it sits in the southern sky at a declination of about -49.
And the problem with it?
The problem is that it's sitting in the middle of an enormous reservoir of cold gas, a node in the cosmic web, exactly the kind of place where galaxies are supposed to gorge themselves and blaze with new stars, and it's making almost none. It's quiet, red, old, and quiet, at an age of the universe that it has no business being any of those things.
Coastal desert.
Coastal desert. Now, the usual suspect for shutting down star formation is the galaxy's own central black hole. It fires up, blows the gas out, and the galaxy starves. Textbook. But the observations showed no sign of an active black hole in the red potato, and no sign of any strong outflows. There was nothing there to blame.
So what changed this week?
Chandra. The team led by Wei-Chen Wang at the University of Milano Bicocca took deep X-ray observations and found a long jet of particles. And it's not coming from the red potato. It's coming from a black hole in a neighboring galaxy, and it's pointed straight at the red potato's gas cloud.
What? It's being starved by someone else's black hole?
That's the finding. The jet doesn't appear to be doing much to its own host galaxy. It's narrow near home, and it widens out as it travels. By the time it reaches the red potato's neighborhood, it's wide enough to stir up that whole gas reservoir. And turbulent gas is turbulent gas. Turbulent gas will not settle down and fall in. The galaxy is surrounded by fuel it cannot collect.
What's the measured evidence for the turbulence?
The gas motions are elevated. They can read that off the shape of the emission lines. It's not proof of causation, and the team is careful about that. They can't fully rule out that the red potato had some earlier violent episode that emptied it out. But there's no evidence for one, and there is a very obvious jet pointing at it.
And this is the interesting bit for the wider picture, because Webb keeps finding these quiet early galaxies.
It does, and they're a genuine problem for our models. If a galaxy can be shut down by a neighbor rather than by itself, then galaxy evolution is not something a galaxy does on its own. It's something done to it by whatever happens to be nearby. That's a considerably messier universe than the one we had drawn.
Let's move on to story 4, Gravity 1 at Open Sea. On Wednesday morning, Beijing time, a rocket lifted off from the deck of a ship 170 kilometers out in the East China Sea, east of Shanghai, and put 9 satellites into orbit.
V-launch is not new, but that distance is unusual.
That is the story. The rocket is Gravity 1, built by a commercial company called Orient Space, based in Shandong province. This was its third flight and its third success, and its first genuine open ocean launch. The previous 2 went up from waters just off the coast. This time the ship sailed properly out to sea.
Why does that matter?
Conditions. The chief designer, Su Guoquang, made the point that open sea is a different problem. Different swell, different weather, no easy shore support. If you can launch out there, you can launch from almost anywhere, which means you can pick your orbit rather than being stuck with whatever your fixed pad allows. It also happens to be China's first commercial sea launch in the Yangtze River Delta.
And the rocket itself is unusual?
Very. Gravity 1 is about 30 meters tall, stubby, squat, 4 strap-on boosters around 3 core stages, and every single one of those motors is solid fuel. No cryogenic propellant, no complex plumbing. You build it, you ship it, you light it. That makes it the most powerful all-solid fueled orbital rocket in the world, at 6.5 tons to low Earth orbit.
Which sounds enormous until you compare it.
And we should. Falcon 9 does about 22.8 tons, so Gravity 1 is roughly a third of that. The record it holds is specifically for solid-fueled rockets, and that is a meaningful category. Solids are simple, storable, and quick to prepare, which is exactly what you want if your business is putting up batches of satellites on a schedule.
But why not?
9 payloads including 6 satellites for a constellation called Huantian, 2 optical satellites carrying artificial intelligence hardware to do image recognition on board, rather than beaming everything down first, and 4 radar satellites designed to fly in formation.
And Orient Space is not stopping at solids.
No, Gravity 2 is the next vehicle, liquid-fueled, recoverable, 21.5 tons to low Earth orbit. Maiden flight targeted for the final quarter of this year, which is ambitious, and the wider context is worth noting. That launch was China's 49th orbital attempt of 2026. The national record is 92 set last year. They're on pace to clear 100.
One more from the Chinese program worth having on your radar.
The big one. The Long March 5 that will send Chang'e 7 to the lunar South Pole arrived in Wenchang on the 13th of July. Navigation warnings point to a launch window opening around the 24th of August. That is a landing mission to the most contested real estate on the moon, and it's now about a month out. In our next story, we visit an old friend for an update, our Starship Flight 13 watch guide.
Quick update on a story we've been following all week, and this one is a watch guide rather than a result, because as we record, it hasn't happened yet.
Flight 13 has had a fortnight.
It has. Back on the 16th, the countdown reached 0, and the flight software called an abort because 4 of the 33 Raptor engines on the booster failed to reach acceptable starting conditions. The limit is 3, so the vehicle stood itself down, which is the system working exactly as designed.
2 Raptors were swapped out after that.
2 Raptors replaced, a leak check on the 22nd, Ship 40 stacked back on Booster 20 that evening, and SpaceX went for it yesterday and then waved off at 4:10 in the afternoon Central Time. Not a vehicle problem. Weather.
Which is a slightly unusual reason to scrub.
It is, and the explanation is interesting. One of the key objectives this flight is getting clean camera footage from the ground of the heat shield while the vehicle is punching through maximum aerodynamic pressure on the way up. Cloud cover means no footage, and no footage means a lost objective, though they waited for a clear day.
So here are the times.
The window opens tonight, Friday the 24th, at 6:45 in the evening Eastern Time. That's 5:45 Central, 4:45 Mountain, 3:45 Pacific. The stream starts about half an hour before.
And for those of us on this side of the world, that is Saturday morning, 8:45 a.m. Eastern Australian Time, 10:45 a.m. in New Zealand. Coffee in hand, entirely civilized for once.
The payload is the headline: 20 Starlink V3 satellites, the first time real, functional V3 spacecraft have gone up on Starship rather than the mass simulators of earlier flights. 6 of them carry cameras aimed back at Starship's own heat shield, so the vehicle gets to inspect itself on the way through.
Plus a Raptor relight in space, a booster splashdown in the Gulf, and the ship coming down in the Indian Ocean.
That is the flight. We will have the result for you in tomorrow's weekend wrap, whatever it turns out to be. And finally today, let's turn our eyes skywards with our daily Skywatch.
We're talking about the sky over your head.
Tonight, the moon has a close encounter with Antares, the red supergiant at the heart of Scorpius, the star whose name literally means rival of Mars.
And this one favors the north, which is a nice change.
It genuinely does, so let us be straight about it. The closest approach happens at 6 in the evening Eastern Time on Friday, when the moon passes about 0.6 of a degree south of Antares. For North American observers, that's right around your evening. By the time the sky is properly dark, the moon will have drifted a little, but you're still looking at a waxing gibbous moon and a bright orange-red star sitting within a degree or 2 of each other. Bring binoculars if you have them. The color contrast is lovely.
And for us in Australia and New Zealand, the exact moment falls in daylight on Saturday morning, so we get the pairing on either side of it, Friday evening and Saturday evening, with the moon and Antares several degrees apart rather than snuggled up.
But with an enormous compensation.
An enormous one. In late July, Scorpius is not scraping the southern horizon for us. It's close to overhead. The whole constellation, the claws, the curve of the body, the sting, is laid out near the zenith in a way northern observers simply never get to see. So take the wider pairing and enjoy the best view of Scorpius on the planet.
And while you're out there, find Altair again, our particle accelerator from earlier. Northern listeners, it's high in the east to southeast in the evening, the bottom point of the summer triangle with Vega and Deneb. Southern listeners, look north and about a third of the way up. Somewhere in that direction, 14,000 light years past it, something is flinging protons at energies our best machines cannot touch.
Good thing to think about while you're standing in the cold.
A few more for the diary. Full moon on Wednesday, the 29th, the buck moon, peaking at 2:30 in the afternoon UTC over in Capricornus, which does mean the sky is brightening all week.
So if you're chasing the Delta Acarids, do it now rather than waiting for the peak. We've said that all week and it still holds.
And in the pre-dawn east, Mars and Saturn are both up. Saturn is the brighter and easier of the two, and the rings are tilted about 9 degrees at the moment, far better than the near edge-on view we had at the end of last year. Worth a telescope if you are up early.
And keep the 12th of August circled. Total solar eclipse across Iceland and Spain, and a moonless Perseid peak the same night. We will have plenty on both closer to the time.
That is Astronomy Daily for Friday, the 24th of July.
You can find us at astronomydaily.io and on your social platform of choice at AstroDailyPod. Astronomy Daily is part of the Bytes.com podcast network.
We're back tomorrow with the weekend wrap and with whatever Starship has done overnight.
Until then, from both of us,
Clear skies.